this problem, we're given that 9 to the power of x minus 6 to the power of x equals to 4 to the power of x. What's the value of x? To start, we can first move 6 to the power of x to the right side to remove the minus. So 9 to the power of x equals to 4 to the power of x plus 6 to the power of x. Then we'll have, notice that 9, 4, and 6 they have some common parts. 9 equals to 3 squared, 4 equals to 2 squared, and 6 equals to 2 times 3. So you'll have 3 squared to the power of x equals to 2 squared to the power of x plus 2 times 3 to the power of x. And then we can rearrange the exponents. 3 to the power of x to the power of 2 equals to 2 to the power of x squared plus 2 to the power of x times 3 to the power of x. And then they have some common parts, 3 to the power of x and 2 to the power of x, which we can set as variables. So we can let 3 to the power of x equal to, we can first let 2 to the power of x equal to p, and 3 to the power of x equal to q. So the equation will become, and we can also move 3 to the power of x to the power of 2, so that all of the terms will be on one side of the equation. So p squared, which is 2x squared, plus pq, which is 2 to the power of x times 3 to the power of x, plus q squared equals to 0. Then I want to find more common parts. So then we can think about, once again, we can divide these by one of the terms, p squared or q squared. But then, before we can divide, we need to prove that they aren't equal to 0. And then, to prove this, we know that if we want to divide by q squared equals to 3 to the power of x squared. This will not equal to 0 because 3 to the power of x is a function. And then if you're a graph, you know that exponential functions aren't equal to 0. 3 to the power of x, for it does not matter what x is, but 3 to the power of x will not equal to 0. So this means that we can divide by q squared. And then after dividing by q squared, you'll have p squared divided by q squared plus p divided by q minus 1 equal to 0, because we already know that q squared not equal to 0. So now we can let p over q equal to another variable as r. To make for easier calculation. R squared plus r minus 1 equals to 0. We can apply a quadratic formula to find that r equals to -1 plus minus square root of 5 divided by 2. However, there's actually only one solution for r, because we know that r will equal to p over q. P over q equals to 2 to the power of x divided by 3 to the power of x. And then we know that since these are both exponential exponential functions, they won't equal to 0. So the quotient will not equal to 0 either. But then, it's not only not equal to 0. Exponential functions, where 2 and 3 are both greater than 0, we all know that this will actually be greater than 0 because by the property of exponential functions, 2 to the power of x divided by 3 to the power of x, both of these functions, the domain will be greater than 0, and the range will also be greater than 0. So we'll have r raised to the quotient will be greater than 0. This means that it can only be positive. So it'll equal to 9, it'll equal to square root of 5 minus 1 divided by 2. Then we can just plug it back in. So we know that r equals to p over q, which is 2 to the power of x divided by 3 to the power of x equals to 2/3 to the power of x equal to -1 plus square root of 5 divided by 2. To solve these kind of exponential equations, we will have to use logarithms. So x will equal to log base 2/3 square root of 5 minus 1 divided by 2. Then you can use the properties of logarithms because this is going to be a quotient or division. So it'll equal to log x minus log y for like the general form. So you can just simplify this. And then the simplified form will be log square root of 5 minus 1 minus log 2 divided by log 2 minus log 3. And then this will approximately equal to 1.19. So that's the answer to this problem.